Assalamualaikum warahmatullahi wabarakatuh and hi. We are from Group 1 for the project in subject of Solid Mechanic code of BNJ 20903. Today we will present about straw load bearing tower. First, let me introduce our group member. I will start with our group leader, which is Nik Ahmad Daniel bin Nik Robidin. Next is myself, Abdul Azim bin Abu Bakaruddin. Sivanathan anak laki Subramaniam, and last but not least, Muhammad Amirul bin Hishamuddin. Next is introduction of tower. A tower is a tall and wide building. Tower will also be constructed for observation, leisure, or telecommunication purpose. A tower can stand by itself or be supported via way of means of adjoining buildings, or it is able to be function or pinnacle of a bigger shape of building. Second, a force is usually applied to a tower in a transverse direction to its upright dimension by curved cable installed between the tower and a distant position. Next, from Oxford Dictionary, tower is defined as a tall, narrow structure that is either freestanding or is part of a larger structure such as fortress or stronghold, then is in the form or include a tower. Load-bearing walls are gauged to the requirement thickness to hold the weight above them, depending on the style of building and the number of levels. Without this, an exterior wall could become unstable if the load exceeds the strength of the material used, potentially resulting in the structure collapsing. This is our problem background for this project. Straw is used as a principal structure material in straw load-bearing tower construction. The model of the tower must not weigh more than 0.7 kg and be between 25 cm in length, 25 cm in width, and 30 cm in height to meet the project's requirement. The project goal is to construct a sturdy and stable tower. Furthermore, the project's recommendation that the ability to sustain the maximum load to be used as a citron. While investigating the highest force applied to the structure, establish a design solution, calculate the loading bearing tower model, normal stress, normal strains, thin cylinder, and column. For our problem statement, first, to build a model of loading bearing tower by using a straw. Next, to construct a robust and stable tower capable withstanding a maximum load until it fails. Lastly, to investigate the highest force applied on the structure. Next is the objective of our project. First, to demonstrate the tower work efficiently. Second, build the tower according to the size and weight that have been set. Thirdly, to show the calculation and solution using solid mechanic theories that involve to the loading bearing tower model. Lastly, to obtain a better understanding of this course.
Hi doctor, my name is Sivanathan Alaki Subramaniam. My matrix number is CN 2048. So today, on behalf of my group, I would like to present about literature review based on our project. So basically, a literature review consists with past researches on a specific subject. The structure of tower was discussed and the theories that I find is issued to calculate in our project problems. In order to get the right calculation, we must understand well about that topic before trying to solve any problem. My first slide is about Eiffel Tower. So it's about tower history about Eiffel Tower. So in this Eiffel Tower, overall the structure has a vertical axis between the two columns, but it's individually as its own axis that follows the curve of the element, which identify as parabolas. The basic structure of the tower is lattice work column at each of the four corners of the tower, in which diagonals connects four elements, thus making stiff but lightweight columns. So Eiffel Tower, that is like one of the tower which is outside from Malaysia. So even in Malaysia, we have a lot of towers like that, like KLCC towers. So one of it, which I took an example, was in Langkawi Sky Bridge. So Langkawi Sky Bridge, located at the top of gondola ropeway, 660 meters above the sea level. The bridge consists of a curving deck, 125 meters long, suspended from a single spindle-like truss tower that leans back at an 80-degree angle. So I've given a picture of it, and that is like on top of the sea of level of 660 meters. So the pylon has an 81.5 meter elevation difference with the deck approximately 55 meters above the foundation at the bottom of the gorge at elevation of 605 meters. The deck is supported by a series of triangular trusses. A pylon is a bar or rod that supports a structure such as a bridge or an overpass on a highway. So it makes it more stronger for it to support. So next I'm going to talk about transmission tower. Actually, basically our project is about load bearing tower. So it's about how much load can a object or can a building or a tower can sustain. So the tower is a balanced construction with four legs that may be used for tower lines with spans of 200 meters or more. The tower consists of a pylon with cross arms connecting by hanging insulators. Why is it hanging? Because during sun days, it will expand the metal in the wires. It will become expand. So when it expands, it will become more straight. So if it's straight, then there must be some defect. So that's why it is created as a bit hanging. So next we can see the transmission towers are classified into tangent suspension towers and angle towers. Transmission line design needs to consider loading from many sources, which the loads on the transmission line tower consist of three mainly perpendicular systems of load acting vertically, normal and parallel to the direction of the line. Weight of the structure after completing the design test with initial weight of the structure by assuming reasonable cross-section area and geometry of the tower. Now we will see normal stress and normal strain. So stress is defined as a force applied per unit area. Normal stress may be tensile or compressive and result from forces acting perpendicular to the plane of the cross section. As you can see, the shape 6 is looks like that. It's called a stress for the formula. So A is the area of force, F is the force applied. So the unit is Newton per meter square. So there is two only, tension versus compression. Okay, normal strain occurs whenever the actual loading of the object responds to normal stress and is indicated by the Greek letter. It's like E, right? It's actually Young modulus. So strain is positive for an increase in dimension and negative for a reduction in dimension. A positive value sign refers to a tensile strain, while negative value is a compressive strain. So as you can see, Young modulus, the E, is the strain due to stress applied, and something like G, it's actually the change of length. Normally it's a triangle. L also it can be written, and L is the original length of the material. So this how is to formula to calculate the strain. Okay, just now we look at normal stress and strain. Now we'll be looking at beam deformation. So the deformation of the beam is usually expressed in terms of its deformation from the particular unloaded position. The deflection shall be measured from the initial neutral surface of the beam to the neutral surface of the deformed beam. Before bending the beam is initially straight position, is of a uniform cross section and has the same modulus of elasticity in tension and compression. In bending of beam, all loads and support reactions are coplanar and perpendicular to the beam axis. The plane cross sections remain plane. The beam must not twist and elastic limit is not exceeded. Okay, now we are going to look on thin cylinder. Normally, thin wall refers to a vessel having an inner radius to wall thickness ratio of 10 or 1 over 10 of the radius of the container. Under this condition, the stress within the wall could also be considered uniform. There are some of application of thin cylinder that used in industry like pressure tank. When the diameter of the cylinder is divided by the thickness of the diameter and has a value larger than 10, that means the cylinder is thick. But if the value is smaller than 10, the cylinder is assumed to be a thin cylinder. The function of this to calculate the state of the stress in the thin cylindrical or spherical pressure vessels. So we can see that cylindrical vessel with principal stress and spherical vessels. So a spherical vessel, a closed structure containing liquids or gas under pressure. So the 6, I mean this looks like 6, right? So it's actually a hoop stress is equals to longitudinal stress which is equals to force, and the R is equal to inner radius over 2t. T is the thickness. So, and then MOH as most circle for in a plane transformation reduces. So that is like shear stress is equals to hoop stress, and that hoop stress is equals to longitudinal stress is constant. Column are longer slender members subject to an axial compressive force. The lateral deflection that occurs is called buckling. A column will buckle about the principal axis of the cross section having the least moment of inertia. So PCR is equals to pi square EI over L square. L is the moment of inertia, E is the modulus of elasticity of material. Column with various types of support is actually basically two formulas. One is Euler's formula is PCR is equal to pi square EI over KL square, which is equal to E square EI over LE square. So to calculate the critical stress, buckling stress is equal to buckling load over cross minus sectional area. Otherwise is stress CR is equal to PCR over A.
Assalamualaikum. Hi, my name is Muhammad Daniel bin Rubidin. Metric number is AN 2006. So I will explain about the project methodology. First, we make a flowchart. That is, first we start title given by lecturer, project information, then sketch the tower design, prepare item and materials, build tower model, test model, report project and presentation, and finally we end. Then we do a planning. First, we read the query or notes, sketch the tower drawing, build tower, and run the load test. Data collection and design selection. So first, we collect source of information from the most of the article on the internet, and then design inspired by the signal tower and have a rectangle shape on each structure to support. Because the rectangle shape is a more stronger shape, so we use this on our model tower. Then working process. First, we sketch the tower. Then we gather all the equipment needed, bought all the needed equipment, make a tower post, and then attach the post to make the floor, and then attach all the framework, and done the full tower. And model testing. First, we try with the 5 kg, and we up 5 kg each time. So from the data we get, our tower passed the 30 kg load. Thus, our tower will successfully achieve our objective, that is to hold a 30 kg load. That's all from me. Thank you.
Assalamualaikum Dr. Nuraini. My name is Muhammad Amirul bin Shamdin, metric number AN200101. Today I want to present about result. Okay, first table show the ability of tower can stand, and our project can stand until 30 kg. And next table is show the parameter of the tower. Okay, next is calculation about the normal stress. The strength of force or force per unit area acting normal to area is known as normal stress. The formula of normal stress is P over A. First, we find the area by R squared O minus R squared I. R squared O is the outer radius and R squared I is the inner radius. And next is P is the force acting on the tower. 30 times 9.81 equal to 294.3 Newton. And we substitute the value of P and A, and we get the normal stress is 68.92 megapascal. Next is the normal strength. Straw is made from polypropylene, and the Young modulus of the straw is 1325 megapascal. 30 kilogram load is put on the top of tower. The stress is assumed to be evenly distributed to each support straw, and the formula is normal stress over Young modulus, and we substitute the value is 0.052. Next is Residing Cylinder. Calculate the hoop stress and longitudinal stress operating on the top of the tower due to the straw under 30 kg loads, using 26 straw to make up the top of the tower. We find the P equal to 30 times 9.81 over 26, we get 11.32, and we calculate the hoop stress PR over T, we get the 1.30 kilopascal, and the longitudinal stress is PR over 2T, and we get the longitudinal stress is 650.9 Pascal. Next is the column. The structure can withstand up to a particular amount of force when the force is applied. At some point, the tower can crumble or collapse. The critical load is the greatest force that a structure can withstand before failing. The formula of column is PCR pi squared EI over KL squared. First, we find the I, and we get the 2.47 times 10 power of negative 11, and we calculate the column. We get the volume of column is 10.34 Pascal. Okay, next is the conclusion. At the end of the project, we get more knowledge, and we consider the length, width, height, and weight of the structure. We also achieve our objective, which is we have learned how to apply the knowledge with a solid mechanic concept in this project. Truss design is the most important aspect because it supports the load and boosts the tower rigidity. As a engineering student, we must know what to make a structure perform efficiently while also being resistant to failure or collapse in order to ensure the safety of future user inhabitants. Hopefully, this project can be a guide for us in the future. Okay, next is recommendation. Give students a lot of practice in stimulating and applying their understanding of how to construct a stable tower base. To improve the construction of distro in the future is to add more truss to make it incredibly strong and solid. Construct tower weight is only 0.175 kg and can sustain a load of 30 kg. We need to learn more about mechanical engineering in order to build a better tower that can withstand more load than the previous project. Thank you. That's all from me.